aircraft building in Gulfport. Some rotors over there. Some more rotors. Got a Blackhawk right over here. Got another one.
Some up to 1,900 shaft horsepower. These came off of a bike model, which is the latest and greatest that we have at our hair salon. It's the bike model. It's called the bike model UH60. Anybody know what UH stands for?
Utility helicopter.
Utility helicopter, absolutely. That's good there. I got any questions about this? Maybe they'll have something I can answer. I got any questions about this? All right, y'all know how it works? Okay.
Air go in, go boo, and go out, make big.
Well, yeah, kind of, sort of. So remember this: suck, squeeze, bang, blow. Got it? The air comes in here, it sucks the air in. Compressor squeezes it. This is the compressor right here with Andrew.
I'm a child.
This is the compressor right here. It squeezes it. And in here you have the combustion. And then as you go across here is the power turbine. So the power turbine actually comes back through with the shaft and spins the high-speed shaft on the end, which goes into the seat box, which runs the transmission, what we call the 5-pack, which actually turns the blades on the helicopter. You got all that? You sure? All right. So what did I tell you? 4 things. What was the 4 things? Suck, squeeze, bang, blow. Got it? Suck, squeeze, bang, blow. All right, cool. All right. Let's roll. All right. This right here is the
This is where the tail rotor, that would be where the tail rotor is located. And this right here would be where your, elevator is going to be. So they got the engines out, they got the rotor off. Hello. Welcome to the live. It's like the top, like near the engine cover for a medical helicopter, and then a regular one. Typically a Blackhawk. Speaking of which, there's a Blackhawk right there. You can see the nose right on is up. Alright. Engines are on. You guys working on some other parts.
Cargo. Huh? Cargo? Cargo helicopter.
Jameson said no. Jameson said no. I think it's cargo.
You said combat and cargo.
It's a...
But it doesn't do that, so no.
Yeah, check out the blade.
Wow, they're a lot bigger in person.
So it's got a total of 6 blades on it. You got 6 blades on there, and they're timed specifically where they don't run into one another, because timing is very important with the Chinook, because you got blades in the front, blades in the back, right?
That's
Very
not a Chinook,
important.
that's
This is
a
what a Chinook
Blackhawk.
looks like. Y'all don't know.
That's a Chinook.
This is what it
I
looks
always wanted to know
like.
how those blades didn't take each other.
We actually had one. I actually saw one land here yesterday.
Yeah.
Yeah.
So
Got a
anyway,
video of it.
so this
I'll
thing
post it
is
on the YouTube channel.
amazing. To me, I think it's one of the best aircraft in the Army inventory, if not the best rotary wing aircraft in the Army inventory.
Now, if you lose one engine, the other one takes over?
Correct. Yes. So they're dual engine, and we call that redundancy.
Redundant.
So redundancy, anybody know what redundancy means? Redundancy means that you have life systems inside here that control the aircraft, such as hydraulic systems, electrical systems, your engine, your propulsion systems, right? You have multiple systems inside the aircraft. So if one of them fails, the other one takes over. The reason for that is, if you break down, you can't stop on a cloud and repair it, right? So you have redundancy systems. You have backup generators. Everything inside this thing, and really truly the way Boeing designed this thing is very unique, because a lot of the systems we're talking about, on one side of the aircraft is one electrical system, on the other side of the aircraft is another electrical system. So if it gets hit from this side or that side, depending, you still are able to continue on with the mission, because you can take hits on this side and not damage any of the thing because you have redundancy systems. It's a very awesome aircraft. Even these right here at the bottom, these are fuel cells, right? At the bottom where the fuel cells are at, they are self-healing.
What are those?
Self-healing fuel cells. So when you shoot at them, you shoot holes in them, they heal themselves. They're designed to seal and heal themselves. It's a very awesome aircraft. I love it. I froze my butt off flying in one of them too. They don't have a lot of heat. They got heat for the pilots, but they don't have heat for the people in the back. Let's move forward. What's up there, Mr. Childers? Anybody tell me cross on the side of that aircraft?
It is a medical Black Hawk.
It is a medic bird. That is right. It is designated as a medic bird. Hence the fact that it has a cross on the side.
Yeah, it didn't even look like that. It didn't even look that big.
You got your shaft and flare.
Down the engine shop.
Got your tail rotor, your main rotor, your engines, all that good stuff. Over here, I believe we have the paint stuff. If you look in there, see something very interesting. Two very interesting things.
It's called the OH-6. Does anybody know what OH stands for? Helicopter.
Observation helicopter.
Observation.
Observation. That's exactly.
Colin said that. One in the white shirt said that. I just said it.
Check that out. Got our OH-6 Soyuz and our Chinook. I'm going to post a video of this specific Chinook landing, because it actually caught landing. We got two sun countries. Look at her. That is cool. Hello, football best editor. Hope y'all are enjoying the video or the live. Look at that.
How many horsepower can you take one engine? Hold on. Come. Hey, the man! Hey, man!
Uh-oh. Whoa, look at that. Look at that. They're bringing the Black Hawk out. How cool is that?
Anybody guess how many horsepower that engine is?
3,000.
How much?
3,000.
Wrong. Too low.
Wow.
6,000.
Too high.
4,000 power.
4,000 shaft horsepower. 4,000 shaft horsepower.
Fun fact, this is the same
Yes.
type of engine that they used
So-
on the SB-1 Defiant.
What's that?
This is the same type of engine they used on the SB-1 Defiant experimental helicopter.
So, yes, I think so. So also, so he just said they used these same engines on the experimental helicopter. That is correct. They also use these engines on Miss Budweiser. You ever heard of Miss Budweiser, the racing boat? The hydroplane, the Miss Budweiser. So Miss Budweiser is one of the biggest racing boats there is out there. They use these type of engines of life.
How many miles per gallon do they do? Only miles.
So, I was, the way I know it is pounds per hour.
Why is there a child here? There's a little child over
1,000
here.
pounds per hour. That's what they take care of it.
Baby in the Avcrad building.
So, those little ones are there, max on those little ones are 800 pounds per hour. These bigger ones up there are 1,004 pounds per hour. Because when I used to test them on the test cell, I used to be the lead over the engine shop. And I used to run them on the test cell and test them. And I used to test them on the test cell. 3 limitations that we were limited by were speed, heat, and fuel flow. Why would you want to be limited on fuel flow for an engine when you're testing it? Anybody know? It's more mechanical failure. No. Next question. So, stop and think about it. If you're a pilot, right, and you got to go from point A to point B, right, you can only put so much fuel in these tanks, right, and you can only go so far. So if you're using a mathematical calculation of the ratio of fuel for the fuel flow to see how much fuel is burned, when you do that mathematical calculation, you need it to be within a certain parameter so you'll know how to make it to point B so you can get more fuel to reach your destination. If it burns more fuel than what it's supposed to, you ain't gonna make your destination. So that's why there's a limit when I test them on the air, when I test them on the test cell, I have to make sure that they're within that limit so they don't burn more fuel than what they're supposed to. So they have to be limited by that. They're also limited by speed. And what I mean by speed is speed inside, what we talk about the speed inside the compressor and the speed inside the power turbine. It's a percentage. And we call it N1 and N2. N1 is your compressor, N2 is your power turbine. The compressor's in the front, up there where you see the nose cone, that's the compressor. And in the back where you see the long metal piece, not the back, but this piece right here, that's your power turbines. I'll get more to that when we get into the engine shop. So we're limited by speed. Each one has a different limit of speed. N1's limited by about 102 to 104%. And N2 is limited right around, I would say, I think it's 110 to 115% on N2 as far as speed. And the next limited factor when you're looking at engines is heat. Heat is your enemy because you're only allowed to go so hot before the metal parts in the engine start breaking down, right? Because anybody knows when metal gets too hot, it does what? Melts, right? It does expand.
It
You're
becomes
absolutely
goopy.
right. So expansion is a major. Now I'm glad you mentioned that. When it comes, who said expand? All right. So when it comes to expand, that's why these engines are made out of a certain type of metal, because inside they're close tolerance. The heat is only allowed to go so far because if it expands too far, it's going to lock up. That's why you're limited on the heat. So the expansion is a big part of it. Great, that's great, that's great. Because they're very close tolerance on it. When I tell you they're close, I mean they're close. I'm like, we're talking, you know what a thousandths is? Anybody know what a thousandths is? Yeah. So how thick is a thousandths, just relatively speaking? If I was to say, huh?
About a hair.
A hair is about 3 thousandths. Wow. A red hair is about 5 thousandths. A blonde hair is about 3 to 4 thousandths, and a black hair is about 3 thousandths. There's, believe it or not, there are smaller measurements than that, but we ain't gonna get into that.
What about a white hair?
A white hair? A white hair don't measure anymore. It ain't what measures.
Hey.
I got a bunch of them. Come on, let's go to this. Oh wait, let's go. I want to show you some of this. Check this out.
This is cool.
You on live?
Yeah, I'm live.
Anybody on there?
Oh yeah, I've got 10 people live. Y'all check this out. Look at this goober. Check this out. It's oh wait, check see.
See something similar to a blind in special forces. Anybody know what? Huh?
MH6 Little Bird.
What is it?
MH6 Little Bird.
Yes. They call it a Lotus.
Yep.
is what they call it. This is an 086 little bird observation.
Yeah,
They
Sage.
flew these in Vietnam, and not too many people around that flew them anymore. This is a museum piece that hangs on a pole out there that we have out there. We have displays and all. They can build the whole thing. Yep. Did you ever get a chance to use that paint
I need some more.
for the aircraft?
I need some more.
Well, I don't have any more. That's all I have.
I did. I used it on the little helicopter.
On the little
that we
helicopter.
built. You know, the last time.
Yeah.
And we took it upstairs to Vietnam.
I need to come down there and see
That's
it.
what I did. I'm sorry. I copied everything you had. Yellow, orange, green, black.
Good.
You know, it's not a. One day I'll have one like this.
Oh dang, we got 14 people in the line. Them some pretty good numbers.
You know why I don't get it so calm? Look at that aircraft. See that air pylon on that aircraft? So that air pylon used to, when we had the old paint hanger, it was down low. Before we had it, we had to take the air pylon off to get it into the paint hanger. So when they built this one, they built it high enough and now we don't have to take anything apart on the aircraft. Pretty awesome. Y'all ready to go to the engine shop?
Yeah.
Alright, so
Chat, y'all ready to go to the engine shop?
listen up. This right here, that's a blast booth. Y'all know what a blast booth is? A blast booth is a booth where you take and put stuff in. You turn it on. You turn it on. When you turn it on, you got a light that comes on. Light comes on. Put your hands inside here. You have the part inside there. You have a wand when you go in there. You have media that comes out of here that blasts the stuff, the metal. So it doesn't hurt the metal. It doesn't pit the metal. It doesn't scratch the metal. It just takes the paint off the metal. Ooh, pretty awesome if you think.
Okay. Oh look, these are the 086 Safes rotor blades. Whoa, this is a very empty room.
Check out modern technology. Watch how the lights follow you.
Hello!
Motion detected lights. Well, it saves the government thousands and thousands of dollars a year because as we're in here, it comes on. When we leave here, it goes off. Most people don't turn the lights off when they leave. So since they got motion sensitive lights, it saves. Can you imagine how many thousands of dollars it would save a year? Everywhere has motion sensitive lights. But here's a good thing. Think about a motion sensitive light. So the light don't come on until it detects
Motion.
movement. That means you got to keep moving at all times in order to keep the light on, right? Keep that in your head. That might stick a little later on.
I need to put those in the museum.
Yeah. Oh, but
It's
yeah,
a wash rack. It's where we wash aircraft.
That's where they wash.
whoa, look, we got a... Check it out, chat. We got a Black Hawk taking off. Black Hawk downstairs.
Right now, everybody know what he's doing right now? What he's doing right now? Listen up. What he's doing right now is he's doing maintenance operational checks, right? That's called MOC. Anytime a pilot gets in an aircraft, he has a certain amount of procedures that he goes through to make sure that everything is right. He may sit there for 35 minutes, he may sit there for an hour, he might sit there for 10 minutes. He's about to move until he gets all the different parameters right. Once he sees that everything is good, that he's green, he's good to go, then he'll start moving out. Now, if this is a maintenance test light, which I'm not sure that it is, but it does appear that it might be from the way that he taxis in that corner. If it's a maintenance test light, what he'll do is he'll taxi out to the end to the compass. And the compass is an area where they pick up They go north, south, east, west, and that's where he does the controls. He wants to make sure that if he makes it go left, it goes left. If he makes it go right, it goes right. If he wants the tail to go left, the tail to go right. He checks all the controls out completely before he takes off flying. Once again, the pilot wants to make sure that it's completely operational aircraft before he takes off flying, because I say again, aviation is a dangerous business. Just take it off, see? Now watch, you'll probably go to the compass and you'll see if you'll pitch forward, pitch backwards, go left, go right.
Chad, how cool is that?
You'll see what he does. Watch what he does. See, he's rolling it. So what he's doing is he's checking everything out. He's making sure that everything is doing what he wants it to do. This is all part of the test. You'll go up, you'll go down. Watch, you'll go back down, watch. So what he's doing right now, the crew chief's sticking his head out the window and he's watching, he's telling I got ground at so many feet. He's looking at his gauges and he's making sure that his gauges are reading properly. So those gauges are, everything got to be reading right. So watch what he's doing. It sounds like he's doing. So what he's going to do right now is he's going to do a head check. Listen, you'll hear it. He's going to go up in it. He's going to go up in RPM. What he's doing, he's going to check the power of the engine.
Oh dang, we've got 24 people on the line.
You'll see him check, you'll see him jerk up, you'll see him check the power of the engines and make sure that the engines are making power. He does it to check. Pretty cool what he's doing right now. They have to make sure all that's right. See, listen, now here they pulled the trim out, listen. Hear how it changed? Now how did that change? You know what changed? So those blades have dampeners on them and they have hydraulics and they do like this. It tells it to pitch, right? So when he changes the pitch, right? What he did is he just flattened it out. He flattened the trim out, right? So he's not really grabbing right now. So here's the thing about a helicopter. It's kind of funny, right? A helicopter does not fly. It beats the air into submission. Think about it. A plane flies because when a plane takes off, and I'm sure y'all learned about this in aeronautics, right? Y'all learned about this. The air goes over the wings, right? And it causes a what? It causes lift, right? And then so...
They know all the four forces. What are the four forces?
Yeah, what is it?
Say it.
Lift, thrust, drag, weight.
Lift, thrust, drag, and weight. Man, I got all that going on. Anyway, you can hear the difference, right? We just kill it right now.
Isn't that cool? Now, which one of these are you guys going to the museum? Both of them?
No,
No?
I can't.
There ain't no
I
chance.
don't have anything to do with any of that. As a matter of fact, those are some pet projects, I think, for some of the hunters this year. I don't know if they plan on putting one on a pole or what they plan.
It's a Black Hawk and a Huey.
I have no authority over any of that stuff.
The Huey's the type that my uncle flew in Vietnam. He flew Hueys to drop off troops at the front lines. Pretty neat guy. Now we're going into the engine shop, I believe. Y'all ready for the engine shop, chat? Got a sneak peek over there. We're going here in a couple minutes. Oh, Cessna jump scare. Look at that. This is where the magic boxes are fixed. aka the engine.
In my humble opinion, and it's only my humble opinion.
No sitting down, nobody sits down.
In my humble opinion, this is the most important shop in this whole outfit. And the reason I say that is, without engines, you can't fly, right? So I think this is an extremely important shop. It's near and dear to my heart because I worked down here for years. But what these guys do is absolutely amazing. It's absolutely a wonderful thing that they do. So if I'll take the time to go through this engine with y'all.
Check it out. Little 146.
And once again, I told y'all, what was the 4 things I told y'all about this engine?
Some country flying over there.
Y'all remember what I told you? What?
Suck, blow,
No, not suck, blow. Suck,
compress.
Suck, squeeze,
squeeze,
and
bang,
bang.
blow, right? Those are the 4 things you want to remember, right?
That'll
Now
never
look,
not
I'm gonna
be funny.
explain those to you right here. Y'all come around, watch. So the suck is, I'm gonna explain to you how this engine works. There's a starter that's mounted right here. Air goes into this starter. As it goes into here, it goes into this gearbox. When this gearbox turns, right, it's a 1-to-1 ratio. As the gearbox turns, it begins to turn the compressor. As that compressor begins to turn, it begins to build speed. As the speed builds up, the compressor starts compressing the air. As it's pulled into the intake, this is the intake. As it's coming into the intake, it's coming into here, and it's being pressurized, right? Now, each one of these things, there's 6 stages right here that goes in here to these different stages. Each one of these stages, as it goes through, it's compressed. When it comes through the compression and goes into the combustion chamber, this is a combustion chamber right here, right? Goes into the combustion chamber, then that's where it actually starts turning the turbines that turns in the very back. This engine is unique. Most engines that you'll see that are turbine engines, the turbine thrust is what goes out, right? Like a jet engine, right? The thrust is what pushes it out. The thrust on this one is just exhaust. It does not cause it to propel forward. What causes this engine to propel forward is there's a shaft that runs all the way through to the front. If you'll turn around and look, you see that big long silver shaft right there? Right there. That is called a power turbine. And the power turbine has 2 stages, and the GG rotors have 2 stages. The GG rotors are what turns the compressor, and then the compressor in turn turns the GGs, and the GGs fuels the power turbine as it goes through. Now, as we were talking about aircraft earlier, what was I telling y'all? What was the 3 limitations that I was telling y'all that we had to worry about? Y'all remember? Speed, right, is a limitation. Why? Because inertia can only go so fast before something tears apart. So when you exceed a speed in the areas, in any area, the power turbine area or the compressor area, that's a problem. You could only take so much inertia. The second thing that I told you was fuel flow, right? Why would you want to limit fuel flow on an engine? Why would you want to make sure that's within a certain perimeter? Now, I told some of these guys this already, but yes, sir.
So that way the engine doesn't get too much fuel and explode.
That's a good point, and we have a lot of procedures out there for that because you don't want it to get too much fuel and explode, but that's not exactly what I'm looking for. Anybody else?
So it doesn't burn too much fuel, so you can actually make it to your destination.
That is the correct answer. The limit of fuel flow is within a perimeter so that the pilot can use the calculations that he needs to calculate from point A to point B. It's very, very important that a pilot be able to know how much fuel he's going to burn from point A to point B or use that calculation. And the Army always errs toward caution. Usually there's a 10 to 20, maybe even 30% factor figured in to their flight to make sure they got enough fuel. In other words, to their favor.
To caveat on what he just said, so me being a crew chief, I'm not in the front. I'm in the back of the aircraft. There's a thing called fuel burn. I'm in the back and I'm calculating how much fuel we are burning every hour. So that way it lets him know not only how much fuel he has left, but how much he has burned and how much he's burning currently. So that way, when we can figure out how far we can fly forward out into the mission. I'm sorry about that.
No, you good. So that's what this is all about, right? So, but the thing is the limitations on the engine, right? So we wanted to know that. This engine here produces about, I want to say 1,700 to 1,800 shaft horsepower, somewhere along in there, is where it's at. On a good day, that's where it's at. And we do a calculation for that, we call it a 1.0. Is there any questions about this engine? Yes.
Back to looking at the other engine, you had different speeds for the different sections. Are they geared differently, or are they all on one shaft?
So the speeds are, now think about it. So this one right here it actually goes through, like I said, and the shaft goes through this end as it's doing. So they're not really geared differently. You're looking at the way the design is, they're all pretty much the same.
Okay.
But the speeds are different because they're separate sections. The power turbine is not hooked to the compressor.
So there's not a shaft that goes all the way through.
So that, see that shaft right under? It doesn't do anything but connect in the front up here. So the air is the only thing that's blowing through this power turbine right here. The air that is produced through the combustion chamber. And when I'm talking about a combustion chamber, that's where the music happens, so to speak, right? So that's where air comes in with atomization. So what happens when you compress air? What happens to it? Anybody know when you compress it, what it does?
An explosion happens. It causes the piston to go back down.
Right, but we ain't dealing with pistons, we're dealing with turbines. But
Okay.
you are dealing with, like I said, so in his defense, what I said earlier, still it does for an internal combustion engine, those properties work as well. Suck, squeeze, bang, blow, right? So as the piston comes down, it's sucking air into the piston, into the chamber, right? It's squeezing the air as it comes up, right? At the time of ignition, what happens? Spark plug sparks, right? So as it's compressing the air is doing what? It's heating, right?
Yes.
So here's a quiz for you. So we talk about engines. Why does a diesel engine not have spark plugs? Anybody know why a diesel engine don't have spark plugs?
I do.
Because
I'm not a
it
teacher.
compresses, so its compression is so high, it doesn't need spark plug. Because the compression is so high in the cylinder as it's coming up, it ignites when the injector shoots it in there because the air is so hot, it don't need a spark plug. That's how you can get a runaway on a diesel engine a lot easier than you can anything else.
And that's also why it's harder to start in colder weather.
That's why you have preheaters or glow plugs. That's why you have them. So let's go back to aviation. I'm sorry, I done chased the rabbit. We done went down the rabbit hole. All right, so anybody got any more questions? Yeah, what you got?
Is it fuel injector or carbureted?
So it's fuel injected.
Okay.
All right, and there's no carburation on this one. There's what's called a fuel control. And the fuel control is actually behind you right there, and that thing turned upside down in that can. That's the fuel control that he's putting his hand on. You can take it off, just put it back on, you know. That's the fuel control.
So that's like a throttle quadrant.
So it has two, so it has a load demand spindle and a power available spindle. So the load demand spindle is how the pilot pulls in for the load, and then you have power available. So basically you have a load and a power available where he used. So like this, he's flying, up here is the throttle.
Listen.
He's flying up here is the throttle, that's the PAS, right? That's your power available. So he's going full fly, he's going power available. And this is the load demand, he's got it right here, right? He's pulling. So as he pulls in, the load demand equals out. Now, this thing is a whole lot smarter than what you think it is, right? This underneath here is an ECU, and it ain't there. They moved it. There it is. I went to get it and it wasn't there. All right, so this is electronic control unit or digital electronic control unit. They make different kinds, right? So what it does is through this yellow cable and the white cable that hooks up to the bulkhead connectors, it speaks back and forth, and the two engines talk back and forth. So this engine talks to this engine, and they regulate one another as they're flying. It's pretty neat. So if the pilot has the ACFS, what is that? What's it called?
Air control.
Automatic control flight system or something like. Yeah. So automatic flight controls, AFCS, automatic flight control system. When the pilot flips on the AFCS, He's actually sitting up there and the airplane's flying itself. It's GPS guided. It can be GPS guided through and it's flying itself from one waypoint to another. Now, no pilot actually depends on that and that alone, because the pilot has to be able to fly off of instruments and sight dead reckoning, because you're not always going to have a GPS and you're not always going to be flying in an area where you can see everything. Hence the importance of the crew chief, because the pilot's got his eyes on the instruments and he's got his eyes flying. The crew chief's got his eyes outside the aircraft watching everything around so he can see, because the pilot can't be doing this and flying at the same time. So it's very, very important that they work together as a team when they're flying. The crew chief is looking outside the aircraft. He's watching everything that's going on. The pilots are watching the instruments, and one is probably running communications with the tower or another aircraft and watching all the air traffic that's going on. And the other guy is actually flying the aircraft. That sound about right?
Yeah. To go one step farther than where he went. So the crew chief in a Black Hawk helicopter sits directly on the right-hand side, directly behind the pilot. The pilot is on the right-hand side of the aircraft. Anybody know why the crew chief sits on the right-hand side of the aircraft?
I do. Go ahead. No, go ahead.
Because, one, the crew chief can stick his head outside of the aircraft. Two, I can see the tail rotor. The pilot cannot see the tail rotor. It is not humanly possible to take and bend your head around far enough to see the tail rotor. So
They don't have any rear view mirrors.
They should.
Also, I am also, now he has instruments to tell him how high he is in the ground, off the ground. I am
Altimeter.
also counting him down while he's landing. I am making sure the tail rotor is clear.
Remember what I was telling y'all a while ago when he was coming down, the crew chief had his head out, he was watching to tell where he was at, how far he was away from the ground. That's what he was doing out there. That's what he's talking about.
So the crew chief plays a very pivotal role. A lot of people just think, oh man, he's just sitting in the back just doing whatever.
I never knew what the crew chief did. I mean, I always heard. That's fascinating.
Yes.
Yeah.
So
I
the
had
crew
no
chief
idea.
plays. So the crew chief plays a very pivotal role in it, and the reason why he does is he's responsible for the entire aircraft. The only thing he's not responsible for is the direction of flight, because he has no way of putting in input to the controls. Now, 110%, he has open communications with the pilot at all times. I can hear everything that pilot says. Now, he can switch me off if he wants to talk to the other pilot without me knowing about it. He can switch me off through switches if he wants to. But I'm hearing everything that the towers are saying. I'm in the back listening. Everybody generally thinks, oh, well, the crew chief's sitting back there playing on his phone. That's not always the case. Very, very rarely am I playing on my phone back there.
No, you ain't playing on your phone at all. You don't
Yeah.
play on your phone on aircraft. That's unsafe. What are you talking about?
100%. That's what I'm saying. I'm not.
We don't play on phones in aircraft. Don't even listen to that.
Yeah, you can. But no, I mean, if I have my phone out during flight, it's because I'm doing a calculation and I'm using the calculator or something like that.
I have a question for you.
Okay.
Fuel wise,
Okay.
okay? I explained to them, in aerodynamics, we teach that the higher you go, the less molecules of air there are.
Okay.
Therefore, you don't create as much power the higher you go,
All right.
because the fuel doesn't explode like it should. Now, as a crew chief, I just realized that you're in charge of fuel management.
Yes.
That is your job, fuel management.
Yes.
Okay, when I fly my airplane, I use my little stick
Yeah.
and I calculate how many gallons I have when I do my pre-flight.
Correct.
Okay, and then I check it with my gauges, but I don't trust the gauges.
Okay. So.
Your gauges are far more accurate than general aviation gauges.
Yes.
I mean, you're down to
Pound.
pounds, right? A little, so you're pretty accurate. You like your gauges, you trust your gauges.
Yes.
Okay.
We trust them very much.
Yeah.
Are they redundant for each tank?
Okay, so on his aircraft, he more probably on his airplane, he probably has several fuel tanks like we do. We primarily have two.
Me too.
So we have a left side, a right side, a number one side, or a number two side, however you want to do it. So in his airplane, he only has one engine. In our aircraft, we have three. We have the APU, we have the number one engine, the number two engine.
APU stands for auxiliary power unit. That's what's used to crank before you crank the aircraft. That's how you get the air starter to go first, to actually start the engine. So you start the P, APU, you get electrical to the aircraft, and that actually gives you the airflow to get the starter, because it's an air-driven starter to start the aircraft. Go ahead.
So, with that being said, the APU, auxiliary power unit, it only pulls from the number one side. That's the only fuel tank it pulls from. Now, let's say I had a problem with the number one fuel cell, we can transfer our fuels from any different side. So in our two tanks, there's a pass through that comes through. So when you fill it up to that height, it can go from one tank to the other. But once it gets down below that, that fuel is trapped over here. That fuel is trapped over here. So then now you're pumping. So there's 1, 2, 3, 4. I think there's 6 pumps total inside of there that we can transfer. We can cross feed it. We could, however you want to do it. We can move it from one side of the aircraft to the other side of the aircraft. But the APU only pulls from the number one fuel cell.
And that's part of the weight and balance that we've been teaching you guys as well as the fuel transfer.
So what he's kind of saying is, okay, so somebody tell me how this engine starts. Somebody, come on.
Well, I told you I just told you gotta have what?
Air.
Air, right? All right, now we have an issue. All my fuel, I can't use my number one fuel cell. We have an issue, right? Mm-hmm. Now I can't start my APU in order to get my air that comes to the starters to my engine.
Oh, but you can.
Yes, you can. That's where I'm
It's
going.
an emergency system. Listen to what he's talking about.
So we're back to air, right? We know that engine's gonna take air to start. I can start the other engine from this engine.
What?
Yes, that's where I'm going with that.
So you have bleed valves.
So, excuse me,
Sorry.
everybody look at this right here.
So like on the Apollo 13, they had to use the lens.
Yeah, they ain't got them on here. But right here is the line that comes out.
They're probably not going to be on here.
They're not. So there's a big metal line that comes out. It's called bleed air, and it's hooked up all through the top, goes up above the oil cooler, and you can transfer it to from one engine to the other to the APU.
So is the valve on there? So that's called the anti-ice valve.
This.
It's also called anti-icing. So the reason it's called an anti-icing is the valve will open. Right here you have a tube that goes in here in the inlet. See, this is the inlet right here. It allows the bleed air that comes from the power turbine to go through that valve and come up here and pushed into here to go into these veins to pull the ice off of here so it doesn't ice up.
Yeah, because ice is not friendly to helicopters and planes.
Well, the higher you go, the colder it is.
Yeah.
That's why us as crew chief, when we look at the pilot, because we don't have air conditioning, and we're like, hey sir, do we have clearance to climb to like 4,000 feet, and can we get there in a hurry? Meanwhile, because I'm standing outside the aircraft, so let's just say it's 86 degrees outside. I'm standing outside in the broad sun with exhaust going everywhere. It's hot.
Yeah,
and I am
so I
out
just
there
think about
just sweating to death, and the pilots have got vent blowers on them, and they're just living their best life. And
That's not
I'm
funny.
like, can we like get this show on the road? Let's go to 4,000 feet. I'm ready to cool off for a minute. I'm sweating.
I feel that.
So that's one way to think about it. So that's kind of what your de-ice is. Your de-ice just takes it out. And each one of your blades have de-ice in them too. Main rotor blades. They have a
So
de-ice.
there's another way too that he can actually crank the P, and that's using the accumulator.
Yes,
So
okay.
There's a
I'll explain.
nitrogen charged accumulator in the aircraft that works off of a hand pump, and they actually pump it up to a certain pressure, and then he can tell you what to do, because that's
All
not
right,
all I know.
so your APU will start at around 1800 psi. So
Of
now-
nitrogen pressure on the accumulator.
So tell me, there's actually two other ways to start the peak.
Well,
We ain't got there yet.
we ain't got there yet.
All right, so your accumulator, it has hydraulic fluid on this side. It has high pressure nitrogen on this side. So when he throws the switch to start the APU does not start off of air. It starts off of hydraulic fluid. It has a hydraulic fluid starter. So when he throws the switch up there to start the APU, it releases that nitrogen charge, pushes really hard through there, sends through tube hoses hydraulic fluid at a really, really high, it's like 5,000 psi. Instantly, it turns that starter, and that's how you start your APU. Now, with that being said, the other option, the other way you can start the APU is called an AGPU. It's basically a jet engine in a cart on wheels. It takes the air that it's providing, is basically an APU outside the aircraft. You can take it, you open up this, you hook up this big thing, you crank up the AGPU, bam. Now you can start any one of your engines.
That's only on the ground.
Yes, only on the ground. And that's only, we very rarely ever use that. It's a possibility, but 9 times out of 10, if there's something wrong with our APU, our auxiliary power unit, if there's something wrong with that, we're never going to shut these engines off, because one engine can run that entire aircraft. You can fly with one engine. We don't recommend it. If we lose an engine, even in flight, we're going to land. That's your spare tire. So both of these engines are doing their thing. They're living their best life. So they're right here. They're tied together, it going into the main transmission. This engine has a problem. We're going to call this says flame out. He's going to try to restart it. Might try to start it 2 or 3 times. Once he determines that it's not starting, we're looking for a landing spot.
Why?
It may be a field, wherever. We're getting out of the air as soon as possible. Because guess what? You no longer have your spare tire.
Just in case.
This engine has the other engine has a problem. It's
You're
real.
calling out the sky.
Then you're going into your auto rotation. So does anybody understand how the auto rotation works?
It automatically rotates. Oops.
Yeah, that's why we don't stick our fingers in places we don't know where they're at.
That's a general rule for life. Don't stick your fingers in holes you don't know where they've been.
So auto rotation, you talk about auto rotation. Anybody know what auto rotation is?
Basically, where the helicopter goes, woo, and the air going over
So that's
it.
what they use the pitch of the aircraft, right? So they pitch the blades to catch it, to make the blades go auto rotate, right? To make sure that they have lift enough to be able to land in an emergency. Ma'am, there's nobody in here today. I don't know where everybody went, but there's not. Oh, here comes the mint right there. Can I help you with something?
No, I do. I'm looking for house.
I have not seen him.
Last time I seen him was about 30 minutes ago, and he was heading out the front door.
Okay, so remember what I was telling y'all about suck, squeeze, bang, and blow?
Yeah, suck, squeeze, bang, and blow.
Right. So
Let me hear them say it. Ready? 1, 2, 3, go. Again.
and
Okay.
so remember that works with an internal combustion engine, right? That works with a turbine engine. That works with just about any engine. because you have to have that particular, you got to have air, you got to have fuel, you got to have spark, right? That works with just about any engine that you work on. Anytime you work on any engine, you always check for air, fuel, and spark, right? So right here, if you look, this is what I was telling you about the suck, the squeeze, the bang, and flow. So here's where the air goes into the inlet. You can see it right here, it's nice and pretty and blue. You can see your fresh air going in, see how it goes in. And this is the compressor. So each one of these blades, I was trying to look for something to point with.
Right there behind you, right there on the table, with a piece of metal.
Yeah, here we go. So each one of these blades right here, this blade right here, actually, so this blade right here turns. As they're turning, these stators are what they call solid. So you have a turning blade and then a stator, then a turning blade, then a stator, then a turning blade and a stator. At each stage as it goes down, compresses more and more. That's how you get your compression. So as the air comes in, it's actually being compressed as it goes through here. When it gets to this end down here, right, it hits the diffuser, what we call the diffuser. It comes up, and you can see cool air is going into here and going into these areas, right? You can see cool air going into these areas. Now, cool air actually goes into the turbines, the GG rotors, the gas generator rotors. This cool air actually goes into them for a reason. Remember I told you heat is one of our biggest enemies as far as horsepower is concerned and torque. So we're limited by heat, we're limited by fuel, and we're limited by speed, right? Remember those are the three things I told you we were limited by. So these GG rotors right here, they have cooling holes inside of them. That air actually goes inside those GG rotors and cools the air as it's going through. They also are coated with a special coating that keeps them from temp. It's a special something or another. It keeps heat resistant coating that's in there, right? It's like a white powdery stuff that's on them. Anyway, it makes them last longer. So you can see this right here. This is this is stage, what I call stage 2 and 3. And then you have, so the first stage is next to the compressor, and the second stage is here. That's your GG rotors. Then you have your power turbine. So your power turbine, you got 4 here. That's 2 spinning and 2 that are stationary. It's doing the same exact thing that the compressor was doing, but it's doing it at the power turbine end. When you have your combustion chamber, you see this right here. Y'all know what that is. That's ignition, right? That right there is a fuel injector. You get that, comes in, you got the dome. So you have atomization. Anybody know what atomization is?
Something to do with the atoms?
Like gasification?
Gasification, atomization. So you have a circle, and the fuel is sprayed into the nozzle, and it's circling like this here, and it atomizes the fuel by the pressure, and it's this way. So when it atomizes the fuel, it burns quicker and cleaner. It's called atomization. Anyway, so it's coming through here, so that's where you get your rotation. Now, remember that long silver shaft I showed you there? This is it. See it? It's coming all the way back here, and it's coming out the front bearing pack, the number 1 bearing pack. It's coming out the number 1 bearing and going out, and that's where the actual torque shaft, high-speed shaft goes in, and that's where it goes into the gearbox, and that's where it goes into the 5-pack, and the 5-pack is a transmission, which I told you was a rotor head on top of the aircraft.
So
Any questions?
I have a question. Roger, you asking me if the shaft was all together.
Right.
What I envision is that the compression chamber is outside a tube that's carrying the shaft.
Yes.
Yeah.
Yes.
Okay,
It's not all together.
yeah.
So how do you drive it if it's not?
Air.
What do you mean? How do you drive what? What are you talking about?
The compressor rotors.
Air.
So air is what drives it. So
Okay.
well, so
There's a feedback between the high pressure coming back to drive?
no,
No?
no. So the combustion is what drives it. The GG rotors are linked to it through these bolts right here. You got this right here, and that's actually linked to the compressor. Your GG rotors is what's spinning your compressor.
Okay, so you really have two shafts, one that is the output shaft and the other is
Is-
a drive shaft for the compressor.
Correct.
Okay.
So the air comes in, and see how it separates, see how it's encapsulated. This goes in the center right here.
Okay.
So as this is spinning, it's actually going through this tube and spinning. This is actually coupled with the GG rotors through these bolts right here. You see how these bolts right
Okay.
here? You have what we call the number 4 bearing, which are number 4, I think. Number 4 bearing that actually comes in here and actually spins on the end. You have these little fingers. I can show these fingers to you, I think. Let me show you.
Mr. Rock.
I'm not sure. Is this one that you use to
The zinc type.
And it did, as soon as I took the cover off. All right,
There
so
they are.
here's the GG rotors.
Hey,
Mr.
guys.
Roger,
Mr. Rogers, come here.
here's your GG rotors right here. Now, when I turn this, I am not turning that high-speed shaft. That shaft goes through this hole right here.
Okay.
That shaft goes through there. This is actually coupled to the compressor, and actually, as you spin this, you're spinning the compressor.
Guys, did you notice that the GG things are bent like the wings of an airplane?
Yes, sir.
You'll notice that?
Yes, sir. It
Why do you
helps,
think that is?
it helps get more air into it.
Sure.
It's the high pressure and low pressure component that makes an
It's like a
airplane
rotary
run.
telephone.
It's the same
He's
thing,
using a rotary
like a
telephone.
vacuum cleaner. Oh, look at that. That's what I wanted to show.
Here we
Thank you,
go.
sir.
So you actually see
Look at this.
the thick side
Come
and
take
the
a look
thin
at this.
side.
Right now.
So the thick side goes forward and the thin side goes aft, right? The thick side is you have the leading edge and the trailing edge. The leading edge is the thick side and the trailing edge. You see that looks just like the wing of an aircraft. Look at it. If you look at the end of the wing, you see it, right? Also, if you look really, really close, you can see little small holes in there. Don't worry about that. That's just, it's gonna fall. You see those small holes in the end?
Yes, sir.
Remember I told you that the what are the 3 limitations for an engine that I told y'all? I want y'all to learn something today. 3
Heat.
limitations. What?
Heat,
Speed,
Fuel.
and
fuel,
heat.
and heat, right? All right, those are the 3 limitations. Check this out. See those little holes in the end?
Yes, sir.
That is the air I was showing you in that thing where I showed you the blue that was down there by the GG rotors, the blue that was going in. That's the cooling air that goes into it. It's very, very important. Also, they don't coat them anymore? But they used to be, right? So they used to have a coating on them. Apparently, they don't coat them anymore. I've been out of the business a while. So they did have a coating on them that was actually designed to be a heat resistance coating. And it was supposed to make them last longer. I don't think it worked, did it? No, it didn't work. So that's why they quit doing it. This is a curved coupling. This is what couples it together with the other GG rotor. As you can see, they're put together here with these 5 bolts. So let me teach you a little something that most people don't know, and you probably don't care, but I'm gonna teach it to you anyway. All right, so right here, you see this bolt right here. There should be one that's, I can't see. I ain't got my glasses on.
What color is it?
All right, so there should be one that's marked with a black tip on the end of it. It's got like a black tip where they marked it.
Right there, it looks like.
Keeps them glasses in a case.
I was gonna say this one.
Yeah, so you see that one right there that's marked with the black tip? Now, more than likely, if you'll look, there should be a little circular thing on there. It's a balance mark. I think this is, I can't see, I ain't got enough light.
Do you have a cold? Look at me, Sid. I just got over a seconds.
Oh, where's the balance mark? I can't see it. It's gotta be on there, so yeah, thank you for the light. Where's it at? Where you see the 0 at?
Sorry.
Where y'all see it? Should be like 2 little half
Moons.
moons that come together. That's a balance mark, and that's how you got to put this thing together.
Oh wait, I thought I saw something.
Where?
Ah, is this it right here? Or is that parentheses?
I didn't get that. A bracket is either of two tall four or back facing punch.
That's it right
Thank
there.
you, Siri.
We
So-
didn't care.
So basically, when we put it together, there's a balance mark on there,
Oh,
and I think you found it. It's like a little zero,
Yeah.
but I didn't see
Kind
it
of
on
like two
that one.
parentheses close together when you don't have anything in between them.
Yep, that's it. That's the balance mark.
So
There
is
it
there-
is right there on that one. See that one right there?
Yeah, right there.
See that?
Mhm.
That's the balance mark. So it's key.
It's more
that
than an ant.
what we call, it's called the long bolt. But the bolt itself, there's nothing anything different about it than the other one. It's just called the long bolt in the instructions. But the long bolt is actually what goes where the balance mark's at. That's to keep it in balance. Why do you think keeping everything on this thing is important to be balanced?
So that if it gets imbalanced, there's a chance
It'll
that
tear itself apart. It'll tear itself apart. If it gets imbalanced,
So it
it'll
won't
tear
get
itself
imbalanced.
apart. So everything's got to be balanced because it spins at such high speeds. So the power turbine speed, correct me if I'm wrong, is what, 22,900?
22,500. That's what it
So yeah, so the power turbine speed is 22,900, and the compressor is, what'd you say, 44 what? 44,000 RPM. Can you imagine if that's out of balance?
You're in a mess of trouble.
If that's out of balance, we're gonna have a major problem. All right, so let's give this back to Mr. Dieter.
Can we take them to the blade place so that you make the blades and repair the blades?
Sure.
That would be
The
awesome.
blade shop? Yeah, we
Yeah.
can take it.
Okay, what is going on with blade?
Check, y'all ready for the blade
So,
trap?
so what do we, watch what I'm doing. So y'all watch, pay attention. What am I doing? I uncovered it, so what am I doing?
Covering it back
Why am I
up.
doing that?
So Dust
So-
and Judd don't get in it.
So spies don't find it?
But we call it something else. What's it called?
grime.
FOD. FOD
Foreign
is
object
anything is a foreign object, and FOD is one of the most crucial enemies of anything to do in aviation. It's anything that's left outside. So if it gets in there and it causes damage, it's called foreign object damage. It can be a rock, it can be a chip, it can be anything. So you seen what I
Yeah,
did, right? I
Dorito
put the
kicks down
faceplate
an
back on, put the seal back in, and I covered it back up, right? Remember that in aviation, anything that you uncover,
Cover it back.
you need to make sure that you
Connor,
cover
if you
it
have a
back
call,
up,
please step away from me.
especially if it's in maintenance.
Ain't
It's
calling, so-
extremely important if it's in maintenance because just like I walked in this shop and there wasn't nobody in here, right?
Right.
So what if some yahoo comes down here that doesn't know anything about what's going on, some supply specialist or whatever, and they're sitting there doing their ink pen like this right here when they walk in, and they're like they're not paying attention, and all of a sudden, bam, with the spring on the end pushes the thing outside the ink pen and it shoots up and it goes right down in one of these engines, and they just a supply specialist. They don't care nothing about it. They're like, oh man, my pen broke. Well, the guy, nobody's here. So if it would have been covered, nothing would have went in there, right? It's always
Especially if he
important.
doesn't tell anyone, and then they.
And 9 times out of 10, some supply person ain't gonna say a thing in the world about it. They gonna say, oh, my pen broke, they could care less.
You know, that's
then
the
you got a
same
mess
thing
of
that
trouble.
happens when things disappear at the museum.
I don't know where the knives
Specifically
went.
Skittles.
Human beings are afraid to tell the truth, which is lack of integrity. Because if you did something by mistake, you should always report it, especially in aviation.
Especially to your parents.
Especially in aviation.
The Skittles incident.
And the knives are missing.
Oh no.
And it fell inside one of the fuel cells in one of the fuel lines. 6 hours later, and taking apart nearly the entire fuel system, I had to put that bolt and that washer in our QC's hands. That's our quality control, to guarantee that that is not inside of there. And then he had to turn around and buy off everything that I had to put back together to get that bolt and that washer out. It is that serious. They do not play.
What are you doing?
He's doing
Live
live.
streaming.
He is live streaming. There's
Yeah.
actually people watching this
face.
probably.
Yeah,
all
12 people.
Got like 12 people.
12 people.
There's like 33 people on the live stream earlier.
All right, come on, let's go see the
Well,
video.
well, that's not good compared to 99% of people.
Oh look, the Sun Country's playing. Look. Dude, bro, move your hand. I'm trying to film Sun Country.
Taking off a couple seconds
Sun
ago.
Country. Nice. Double Sun Country. Whoa.
If you was with me, follow me. If not, stay here.
We is with him.
What are you doing here? Are you all?
Francisco, say hi to the live
Hi,
stream.
how are you? Doing great.
Like the video.
Come to the Mississippi Aviation Heritage Museum.
Yeah, come visit us.
Put
You
the
see-
like on the video or
Thank
you're a
you, thank
donkey.
you to Gulf Island T-shirts. They gave us the T-shirts.
Yeah.
7. We got a stowaway.
Yeah, y'all visit the museum. It's super cool. Come to the summer camp next year. Y'all get to do this. Might even get to see me there. It's
That's the one that we saw. Remember I asked you why would it have red crosses?
yeah, it's a medevac helicopter. See, this is what can happen if you really like something and you really want to. What in the world is that? Hold up. Is that a C-130 or is that a HC-144? It's definitely like a high wing. I think it's a C-130 Super Herc. Y'all see it? Could be a Super Herc. Yeah, y'all see it? Looks like a Super Herc. Yeah, that's a Super Herc. Look at them coming in. It's a Super Herc. Super Herc supremacy. There it is. Yep, Super Herc. Here in a couple of days, we'll be seeing Fat Albert, the Blue Angel Super Herc. Yep. Andy's lifting. Look at him go. I love a Super Herc. Yeah, y'all come visit us at the Mississippi Aviation Heritage Museum. We got all sorts of different displays, different stuff to do. It's just really cool. And who knows, maybe you'll even get the chance to see me there. An hour and 8 minutes. Oh. Alright.
Stay with the group.
I know, there's a Sun Country plane taking off over there. There he goes.
Keep moving. Come on.
I know.
That foot on one side of the piston, pushing that foot, pushing the piston back and forth, right? See how small and thin that thing is, and look how big and huge this door is. That's the power of hydraulics. You have hydraulics on the aircraft. You got hydraulics on your car. You probably don't know it. You call it shocks or struts, right? That's hydraulics. It's on your car. You have more hydraulics. That's the brakes. Every time you step on the brake, you're actuating the hydraulic system. Every time you step on the brake. So, you see you got line going down here, right? On this side, you got another line here. Once this is going in, the other one's pulling the foot out, right? So it goes back and forth. It's actually designed doors now. And you stop and think about how much that door weighs and look at the size of those cylinders. Hydraulics is amazing.
It is.
Hello! Working on what looks like the tail of Black Hawk. Pretty cool. And Black Hawk's over there doing like wheat, like donuts or whatever on the tarmac. If y'all have questions, don't be afraid to comment. Me when government documents. Man, I'm thirsty, bro. It's hot out here. Cessna jump scare. Cessna jump scare.
Keep up with the team, okay?
I know. Welcome to Rotor Land, the world's favorite amusement park. Yeah, this.
Check it out, right here.
Pieces of rotor.
Come on, guys.
I remember
Guys, come over
this.
here.
Yeah,
He's gonna explain to you how they make the blade.
what the internals look like.
Hey, pay attention. Gentlemen, he's gonna tell you how blades are made. Ready? Go.
Basically, the blade is made up of a spar, fiberglass, and honeycomb. That is the honeycomb you have in your hand.
Not actually made of honey though.
It's made out of fiberglass. You notice it?
Crunchy.
So they got that design from Design the Bee. Bee designs honeycomb.
Hello, Pramod Singh 999.
This is how strong it is.
Nice M4 tattoo.
For de-icing?
No, this underneath here is the de-ice, which goes over this phenolic piece. Spars fill with nitrogen to displace oxygen to keep the moisture out.
Okay.
Nice M4A1 tattoo.
Well, I appreciate it.
We stand the
Alpha
M4 on
Lima
this
blades are
channel.
the only blades that are filled, Mike models have a spar, but it's a sealed unit.
Okay.
The Alpha Limas will have a BIM indicator. BIM indicator turns red, means you got a leak in the spar somewhere.
And that is no good.
And that's to eliminate corrosion.
Yes, and no. But
So can we fix it if it's leaking, the spar is leaking?
No one likes a leaky spar.
That's a done deal, right?
that's a done deal. We get rid of it and send it to CCAD.
If your spar is leaking, you should probably see a medical professional.
No, we said that if the spar leaks,
Can you show us what the
Water.
indicator looks like and how it's, hey, guys, pay attention. I'm sorry.
I know it's on water. Hello, say hi to the YouTube channel.
Stand on one side.
All right, guys, come on. Come on.
put it back.
Put it back.
Look at these.
Check the test the BIM indicator. You just hold it. All you do is just seal off the nitrogen coming to the BIM indicator. It'll start to turn red.
So when these go through maintenance, do you
That looks pretty sick.
put any coating on the inside of the spar? Or just
Spars completely sealed.
Okay.
It's completely sealed. If you notice on the Mike model is a closed unit. It has no fin indicator.
It's not even turning red. Not doing it.
Move your hands, move your hands. Stop. Dude, stop. I'm not holding on. Put his mouth on. Dude, stop. I don't want to catch the tizzle.
I'm gonna go wash my hands.
Dude, autism is not infected. I know.
These are newer blades.
Look at this weak boy. I'm just playing with you, bro. I'm just playing with you. Whoa, what in the Boston Dynamics is this, bro?
This is Vision.
They got a whole Boston Dynamics robot up in here.
Vision. Basically,
Catch that kid up there and make it spin around. Just whoa.
section of the blade, it'll shoot a laser into the, and it'll basically take like an X-ray of the honeycomb with the D-bomb.
What would happen if you deleted System 32 on there?
Yeah,
You
this machine was technically designed.
try it.
Each one of those panels right here was supposed to be a head for the robot, and it was supposed to, the head that's on there will take the images. It'll actually find and import the exact location of the D-bond. It'll design to change the head, cut out the D-bond for us, and then cut out the honeycomb to do the
That don't work.
No.
We got the vision for it.
We got just the vision portion, just the shearography for the imaging and everything. And so far, it ain't working. So is this on flying? No, this was ones just sent from CCAD. As you can see, they removed the meter mat and everything on it. And by this blade here, we actually found out that it will not take the images without the blade being painted. So if the paint's all the way off of it, we don't get that imagery.
Huh.
That's why sections of it.
Wait a minute, is that like a radar?
Yeah,
Like it's still?
something like that. It's really hard to explain. It's right there how it works.
Alright, so what is Vision? Vision is advanced robotic system designed to support the Department of Defense in inspecting and repairing UH-60 helicopter blades. This system automates the inspection process, improving efficiency, accuracy, safety, and blade maintenance. How it works. Put the blade in. Inspect it. Shearography technology. Shearography is a technique that uses laser
Interferometry.
Yeah, say that 3 times fast. And speckle patterns to detect internal surface deformation. It requires an optically rough surface that involves shifting the laser pattern to capture detailed images of the blade's structure.
See,
Yeah, we got
if this didn't have a
RGB.
function in it right here, when you tap the blade, you hear that thud? That's what we look for when we're tapping a blade out. That's a D-bond.
Why is there a puncture in it?
This is just a test piece. So if we find the D-bond, we'll find the complete area of the D-bond. We'll cut that area out, reinsert the honeycomb, and then we'll put a skin over it, and then another skin over the top of that, and then we'll smooth it out.
What exactly did y'all do to this? Did y'all just take a hammer and go,
Just
"Bah"?
somebody hit it.
Oh.
That's all it is.
They mean to do it?
Yeah.
Let me ask you a question.
Paying attention. This indicator right here is red. What's that mean?
It means not good.
It means it's lost its what?
Pressure.
Nitrogen, right?
Lost its nitrogen in
Why
the spark.
is it important to put nitrogen
It displaces the oxygen to keep from corroding.
in? Okay, it's for anti-corrosion.
To where it gets precipitation,
Yeah.
moisture.
Yeah. Wow. And how often do you have to
An hour,
restore
20-minute point.
We don't really restore, we just repair.
Repair?
Yeah.
Repair.
Blade comes in, just say it's a PMI inspection, a phase maintenance inspection,
Uh-huh.
that we have basically a checklist of stuff to do for that PMI inspection. And one of them is a spar pressure check. We hook up a little box to the spar where his hand is,
Yeah.
and we cut the safety wire that will be on it. We'll turn that bigger valve right here, and it'll send pressure into the box. And it's based on temperature too. We have to let that box sit out to get to ambient temperature. Once it gets to ambient temperature, then we test it, and then we got a diagram we go by. Okay, 80 degrees, it should be at this pressure. And then the machine will tell us, the box will tell us.
What is that? What is that back there?
All right, that is a dehydrator.
A dehydrator.
I'm dehydrated.
We'll blast 47 blades, and then we'll put them in there and dehydrate them for 14 days to dry up all the water that's inside of them.
You didn't have this a year.
Well, we had all this.
We didn't come over here.
You had it?
We didn't come over here. Whoa, secret government secrets. Whoa, secret government stuff. Whoa, I'm gonna leak this on War Thunder chat.
Bottom puts the shade. So what happens in the morning time, there's moisture on top of the blade.
Look at that. Yeah, they got the dopest home screen. It's the dopest looking locks. Wait a second, that's AI. Ain't no way they got AI swap for a home screen, bro.
Once it comes out, we do all the repairs, and then we'll put it on this table, and that table simulates what's going on outside. That's the heat lamp on top, it's got air conditioning on top. And we'll seal it with consistency of water. So if it gets into the cracks, it seals the blade. Nah, not really. They just drew.
Once again, don't be afraid to comment, y'all.
You see that the system behind you is running Windows 11? Is that the operating system used to run the machine?
Yeah, that's what they use. This machine comes from NIAR.
This thing runs on Windows Vista.
National Institute for Aviation Research, and they're based in Wichita, Kansas, at the University of Kansas.
Yeah,
This machine was actually bigger than what it is. It was so tall it wouldn't fit in here, so they had to shorten it.
How many millions did that cost?
They just said here.
They should make a version that runs on Windows Vista.
No, they should.
That'd be funny.
If it works on Windows 11, leave it alone.
That's just what they put in here, and they've already been out here 4 times
To work on it.
work on it.
I wonder what kind of secret government documents are in those folders.
Nothing really, basically just all programming.
You should leak them on War Thunder. As all upstanding citizens do.
For those of you that are paying some attention, okay? Who do you think created and invented all of this? Somebody?
Igor Sikorsky.
Well, amen. Through him. But who?
Igor Sikorsky?
No. You are the
Oh no, that's
creator
the only
of
helicopter
things.
guy I know.
Huh?
I'm putting a patent on it if I created it. I need some
What I'm saying is that you have the opportunity to create, to come up with ideas. Okay, let's put this thing in here, see if it works. Oh, that didn't work. Well, let's do this one. It's called creativity. You got to use it. Not just sit around. Oh, okay, I just want to play games. Oh, I want some food. That's all I want.
I want some food right now.
Not to mention, you do have to follow what the TM and the Denmark tells you to do.
Oh man, there's rules.
Oh yeah, always rules.
Why do
You can
rules
always-
exist? Rules are
We can always
annoying.
put in, how we would do it, other than what the book says, and if it's better, the engineer could give us approval.
Yeah, in aviation, there's a part of aviation that if you can make a part stronger or better, they allow it. Yes.
May I go get some water, please?
Water, I don't know. where the
There's a water fountain up there next to the eye wash station.
All right, well, let's go over there.
Yes.
I'm gonna ask him to take us to the 3D printers.
That's up to the machine shop.
Yeah, y'all support Francisco and the museum. He's a really cool guy, and he does a lot of good work. He's the guy who owns the museum. just a really chill guy in general. Look at this. What are y'all guys doing? What are y'all guys doing? Yeah. What are y'all working on these tail rotors?
That's them. I don't actually work on these, so that's usually the one that was talking to y'all a while ago can tell you about the tail rotor more than I can.
Alright.
What's one about the tail rotor?
Yeah, why are y'all working on these tail rotors?
This tail rotor's done.
Oh, what did y'all do with
When it
it?
has a yellow tag on it like this, that means it's complete. It's done.
Alright.
All this one came in was just for an inspection. Everything inspected properly. Got a TI to come in, buy off my paperwork. Done deal.
Alright. Yeah, I'm live streaming right now.
That's alright.
Yeah. Yikes. I was shutting the door. I don't think your tail rotor's supposed to, I don't think your main rotor's supposed to be bent like that. I think your main rotor right here is a little bent. It's a little bent. This is what it should look like. This is what it looks like. Yeah, once again, if y'all ever get the chance, y'all should go and support the Air Museum. The Mississippi Aviation Heritage Museum. Really cool people.
Thank you.
Well, I don't have one here now. So that's what the thing is. You know, we get stuff in, it goes out. That's the only shield that I know of. We have one flying yesterday.
Yeah, I saw that one land. Now, tell us what these boxes are.
Where the blades go. Blades. That's for the blade.
Alright. Whoa, is this a fuel tank?
This is a fuel tank.
Whoa.
Those are extended life. Yep.
Whoa, that's cool. Check that out. So those are the fuel tanks they put on like Blackhawks and stuff. Put them on little pylons. Like right above where the doors are. This place is awesome. Morning.
So I made you. Do some push-ups. I'll do some push-ups. Yeah, help him in there.
Do some. Drop and give me 20, boy.
Get up there, boy. See what you got. Ready? And 1, 2.
Oh! Oh, he's doing it! That boy is doing it! Wait. Yo, you got Hardee's? Can I get some? Nah, I'm just messing with you. Nah.
Okay.
I'm live streaming right now, by the way. It's out of the live. What is in here? Is this the secret government documents room? Oh, I remember what this is.
Oh, boy, doesn't feel good in here.
Oh yeah. Oh, we got 20 people. Welcome to the live stream, people. We're at the FCRAD building at the Gulfport Airport. This is where they do maintenance on the. Like, if y'all live around like Gulfport, Biloxi, Ocean Springs, that area, and you see like they jamming out building a Black Hawk up in here. But yeah, if y'all like live around Ocean Springs, Gulfport, Biloxi, that area, I know y'all see Black Hawks fly over. This is where they come to. They fly out of here, or they fly in and they fly out doing maintenance. It's pretty cool. Check this out. We got the side doors. Looks like a tail rotor housing. Got stuff for the rudder. You got some engine intakes. That's a part of the tail. These are the engine covers. This is, you know those little humps on the top of the Blackhawks? That's what that is. Like the part that goes like right about there. Yo, nice music. What is in here? Oh, this is cool. This is cool. This is like 3D printing room. This is like 3D printing metal room. It's awesome. Oh yeah, for the people out there who 3D print, we got a benchy, a big benchy, little benchy. Yeah, I've been live streaming for the past hour and a half.
Yeah, we're here. Come on, kids.
Trying to give you all a brief overview of what we do here and kind of talk about the what our capabilities are. So this right here is the machine and welding shop. So what we do is we fabricate parts or tools for aviation. So anything that you can't typically acquire, like a socket or a wrench or something like that, those are easily acquired tools. Something that's for specialized tooling, that's what we originally started as. So something like this. This is a very simple tool, a very easy tool. We make it in 2 steps. We'll use a water jet to cut it out, and then we'll use a drill to kind of make a hole, throw a cotter pin in there. All it does is touch a button. That's all it does. What you got?
Why is there a donkey right here?
Do what?
Why is there a donk horse?
That is our resident artist.
Shout
We
out to
thought it would
Mr.
be-
Adams.
Hey,
Shout out to
wait,
my boy,
wait,
Mr.
wait.
Adams.
Guys, how disrespectful it is and you're not listening to the guy.
Alright. So, back on what we were talking about, making tools. Whenever it comes to making these tools, they have a very special need that isn't easily met using other different facilities, so I can make those tools here. Moving on from the tools, we'll talk about the parts. Aircraft. We have many different capabilities from CNC machines, which stand for computer numeric control, all the way up to 3D printing, water jets, many different tools at our disposal. Once we acquired those tools, we started fabricating parts for aircraft. One that we commonly make that has to be changed slightly, variants on this part is for a 47. This is known as a doubler. What happens is it goes to the aircraft and it reinforces a certain part of the aircraft. Now, something about it is that the gussets on this change ever so slightly for each and every aircraft that it goes on, slightly to the left, slightly to the right. So instead of making it out of metal, getting it wrong and having to make it again, we started incorporating 3D printers. So we started 3D printing the part, applying it. Now there is some slight variance that you get for shrinkage. We accommodate for that. Put it on the aircraft, drill it, say, yeah, that's good. Yeah, that fits. Yeah, that's fine. So then we'll start making it out of metal.
It is.
Now we can't 3D print anything that stays on the aircraft, so we started having to get a little bit more creative with what we do. So we do a lot of reverse engineering. So this shop is here to aid other shops with workflow, with kind of manufacturing of things and coming up with ideas of how to make things easier. So for instance, this was originally a repair done on the Black Hawk that was made in 5 separate pieces. Well, they just needed us to make one of those 5 pieces. We said, why don't we make all 5 pieces at once, all together? So we started making that. I took a 3D laser scanner to the helicopter, scanned the area, pulled some numbers, made a 3D print. They said, well, why don't we add some things here, double it up here, make it a little bit wider here? I said, absolutely, I can do that. We use a 3D CAD software known as SolidWorks to model this stuff up. So then I added those things. Added the additional radiuses, added the additional flanges, added the additional width, and then 3D printed that again. Took it over the aircraft, test fit it. They said that works great. So then we used the CAD software. What you got?
I remember in my engineering class 2 years ago, we used SolidWorks and it was a waking nightmare for me. It was horrible. I did not know how to use it.
So it takes a little bit of familiarity with design processes in order to use SolidWorks. I went through a course, got my CWSA, and I'm working on my CWSP professional license on SolidWorks. What we did was we took that, modeled up again, added the additional parts that they required, and then we took it over to our machine and did using a CAD software, or a CAM software, my apologies. So there's 2 different softwares, CAD for computer-aided design, CAM for computer-aided manufacturing. So that makes what's known as the G&M code. If you've ever done any coding before, it's simple if-then statements. This is kind of similar to that. We'll tell it a command, move to XY coordinate this. Start spinning, move to this location at this speed, create what's known as a cut. We then, once we make up that 1,000 lines of code, we'll then input it to our machines over here, which are right behind you, known as our CNC mills. And those
Very
will
cool.
read that code and create that part out of what starts out looking like this, a solid chunk of aluminum.
Aluminium,
Not how you say it.
as British
Exactly.
people would say.
So, we'll take that solid chunk, put it into the machines, and then our cutters over there will start to make this part out of that solid chunk. One thing I like to say is, what you got?
How long does it take to mill a piece like that?
So something like this would take you anywhere from 30 minutes to an hour, depending on how brave you are. So this one, I believe, took us about an hour, hour and a half.
Yeah, the first draft took an hour, and then they changed things, and the second one took me 45 minutes.
45 minutes. So what happens is, once you start getting a bit more comfortable with your tolerances and how tight it has to be, you can run your machine faster and faster and faster until it starts screaming at you, then back it off a little bit. So that's what we go through here. We're here to help other shops. Have you been through sheet metal yet?
Yes.
Okay. So
In
we'll
fact-
be stealing their thunder by showing off.
Yeah, we got those weird little like lizard dragon things. We got some benchy. I know. Got some.
Show all this. So if y'all follow me, what we have, so I've already shown you my CNC mill, the one in the back. I'll show you my 5-axis because it's a little bit cooler. This is probably my favorite machine. This is a 60,000 PSI water
Still
jet.
water.
So it uses a garnet sand, which is this kind of sand here, which that's absolutely filthy. Oh well.
Is this still water?
It is. Do not touch it. You will
Still
get at least
water.
3 different diseases.
Still
Oh my
water,
God.
guys. It's still
So-
water.
Do y'all know what garnet is? A semi-precious
Those who
stone.
know.
So they take that garnet and they ground it into a fine sand and they mix it with other different particulates, but this is it right over here that he has in his hand.
Whoa.
That sand-like gem is then mixed into the water and shot out of our nozzle here to create a cutting force.
What would happen if you snorted it?
Bad things. Bad things would happen.
You die.
Just
You would die.
Hey.
She snorted it.
Yeah. It would get into your lungs and cut you up.
Would it be the same when you drink it?
It would be very bad. What you got?
Do you reuse any of it, or like?
No, the sand is not reused. We dispose of it using waste disposal, and because it's mixed with metal particles, so like aluminum and steel and sometimes titanium, all kinds of different metals are
How
mixed in with
often?
it, and it's very hard to separate.
Are you one of those who know?
How often do you
He is not the one who knows.
clean it out?
So we clean it out twice a year. Well, sometimes once a year. It just depends on how clogged or how high the bed kind of gets dirty.
Is this faster or more accurate than a CNC router that's cut like this?
Yeah, if y'all have
So
ever
it
seen this like
depends. So if you have
water
like
jet
a
videos,
plasma
y'all know
or
what this is.
a laser, those tend to be a bit more. The plasma isn't. The water jet's a bit more accurate within a 5,000ths tolerance is what it boasts. Now the newer models boast within a thousandths of tolerance. But the routers tend to be a bit more accurate due to the CNC nature of them not having to use a spreading gauge because this is water, it spreads as it escapes the nozzle. Lasers are within a couple microns, I believe, not be that accurate.
There's no disconnected. My
EDM
bad,
is way more
guys.
accurate. You get zero tolerance
Okay,
machining through
right.
EDM.
So he just asked a question about the water. This is a thing, yeah, don't break it. This is a thing that I make everybody read if they're gonna come work with me on the water jet. And basically what it says is that you're working around 65,000 PSI for water. So that stuff injects to the skin that's left on your body. If you run your hand over it, your fingers are gonna stay right there. They're not coming with you. But the
No
particles
more
that get into your
fingers.
body, this water, like he said, is mixed with metals, heavy metals. It's mixed with garnet. And because it's a standing piece of water, it gets bacteria in it, right? This little card right here, it says unusual effects
Still
of
water.
infections with micro
Still water.
organisms occurring at lower temperatures have been reported. They're the same found in sewage.
Yikes.
Drink water.
What would happen if you did drink water?
You would go to the hospital in a lot of
You
pain.
would be very, very sick very quickly. Don't do it. Don't drink the water. Don't snort the garment.
The stuff that is in here is made to cut metal. It doesn't care about you or your skin, and most of the stuff that you will kill you if you don't respect it.
So, what the machine does for us. So y'all have already been through sheet metal and y'all probably seen some of the things that they make. A lot of the things that are more complicated, they will come to me to make for them. One thing being this drip pan right here, which I might have a picture of. Right here, we'll draw out this pan here. They'll give me one that they had originally, and then I'll either scan that or measure it and make a reverse engineered model of that thing, and then take it and upload it to my software here, and then it'll cut that out for me. I can cut about 50 to 60 of these things in the time it takes you to make 2. And I dare you to get that kind of accuracy on those radiuses and try to put a flat bevel on the bottom of those holes. Go ahead. Try to drill out a hole with a flat bottom. Ain't happening. Ain't happening. You'd have to use a punch or something. But even then, it's still not going to be as repeatable and consistent and as quick as what I can get out. So that's a lot of what we do. We help other shops make their jobs easier.
Boy, what is this 1990s looking on computer?
It's Windows XP still, so it is very old. But
Windows XP is crazy.
Best Windows.
Oh, absolutely. All right, so let's talk a little bit more about my machines. Over here, we have the 3D printer.
Personally, my favorite windows is stained glass. In my personal opinion, I think the best windows is stained glass.
It is your standard FDM printer. So it takes this filament. If you've ever used a 3D printer before, it takes a wire-like filament up through the machine, feeds it up to a nozzle, heats it up to about 340 degrees Celsius, and then extrudes it out layer by layer, like the 3D prints that I was showing y'all earlier. Have y'all messed with a 3D printer before? Maybe something? Yeah? All right, absolutely. I kind of figured as much. Most people have one in their homes now. It's very easy to obtain.
I unfortunately do not.
This one is mine. I could fit your 3D printer in my 3D printer.
My 3D printer is bigger than your 3D printer.
Absolutely. Now, does that mean it's better? No.
Yes.
It's faster, it can print larger things, but sometimes a more accurate and consistent, print can come out of something smaller. But this is also really great for what I need to use it for. Big, quick, and repeatable test prints for test fitting things on aircraft, or making caps, making plugs, making tools, just quick prototypes. This is what it does for me and for this facility. Now, let's go over to my 5-axis mill. Let me squeeze through y'all here. I'm sure y'all already know about the 3 cardinal axes, X, Y, and Z, left, right, forward, back, up, down. We have 2 additional axis rotation on this machine. What are these? 2 additional, which is A and C. So you have your X, Y, Z, left, right, forward, back, up, down. A would be a rotational plane in which your part, not the tool, the part will rotate 360 degrees. A would be this trunnion itself. So as you can see here, the part is currently pointed towards y'all.
Yeah.
That means that my C axis, or no, my A axis, is rotated about 90 degrees, which is this trunnion here. So this entire base will rotate 180 degrees to get additional locations on this part that needs to be milled. This is one of the tools that I use to mill that.
Good.
It is small. It is a 1/64 carbide end mill.
It's average size.
When I tell you, this thing removes 1/1000th of material at a time. I mean 1/1000th. So 1/1000th of an inch. 0.001.
It's not that small.
That's what we
It's
operate
average
in.
size.
So the diameter of the end mill is 1/64, which would be 0.015 of an inch. 0.015.
Which would be 15 thousandths.
Whoa, what's she doing?
Oh, it's waking up.
Wakey, wakey, good morning.
That's gonna do some.
Who do you think created something like this?
Barack Obama.
You.
Lord Jesus Christ,
No, you can create something like this one day if you.
So you're only limited by your imagination in this shop. Anything that you think you can create, you can make. If you don't have a way to make it, you can make a way to make it.
I love that. Get that in your nugget.
That's why gun control laws are dumb.
I've been doing this job for about 27 years, machining, and I worked for a little short time at a place called Mazak. So I've made the machines that make these machines.
The machines that make the machines.
Make the machines. I can do that.
So what it's doing is it's taking it to what's known as its zero location, which is all the way to the far left. Then it's moving to what's known as a safe location. So whenever it changes out these tools, it'll come out of the machine like this, spin really rapidly to our turret location, and then input the new tool. This machine has decided that this position at the far front right-hand side of the machine is the safest place to do that tool change. So we're going to run a quick program. I say quick, it's a 15-hour-long program. Now this won't be with the tool. It's just kind of to show how it operates and moves all at once. So you see how all 5 axes were rotating at the same time? Moving to the left, moving back, spinning my part. Now it's coming down in the Z-axis and moving. So what it's doing is it's reading that code. If you look on this screen over here in orange, it's got what's known as G-code. So that is cooling. So what happens is whenever you rub two things together, what happens? Friction. Friction creates what? Heat. Heat does what to metal?
Melts it.
Melts
Expands.
metal.
Expands.
So it expands metal. So whenever you are milling on a piece of aluminum or steel or titanium or any type of metal, whenever you've got a solid carbide or high-speed steel end mill spinning at 7,000 rotations per minute, rubbing up against another piece of metal or cutting that piece of metal, it gets hot. And when things get hot, they get brittle and they break. So we use that coolant to cool off both the cutter that is cutting that metal and the metal itself so that it stays at a workable temperature. 1, so that it doesn't expand and cut off too much material, and 2, so that it doesn't heat up and then cool down and make that tool or cutter or part brittle.
It adds lubricity. So
You built this?
we're not actually cutting it.
He was spitting on, he
shearing
was
off.
putting it in his mouth.
So like on a lathe, when you make a perfect lathe chip, you're making those 6s and 9s, right? Whenever you're using a mill, it makes like little, they look like little shark teeth, little dragon's teeth, right? That's a perfect chip form. That's what you're after. Our job really is just making good chips. Parts just happen, right? Kind of one way to look at it.
Listen, we have 3 more minutes before we have to head on back.
Yeah, if y'all have any questions for me, any at all.
So y'all been taking your...
Chat, y'all have any
did some
questions?
3D printing, right? Yesterday and the day before?
Yeah.
Okay, so imagine doing that in a giant
Metal
machine like
samples he
that
was
one.
showing.
Yeah, so the sheet metal shop were the ones that actually bent them up. What did I do with those?
It's called a gantry mill.
I think they're still over
I
there.
had 75
Chat, do y'all have any questions?
I'm over 5 right now. I'm going to ALC
30 feet wide.
next week.
Chat, y'all have any questions about the
January.
Yeah.
about
You can build
the that thing? 3D or the
It helps when you
metal cutting machine.
All right, everybody clap.
You know what's fun to see who's this street building?
Oh, absolutely.
I started it then.
I hope y'all enjoyed that. I'll be going live in here in a little bit again. Next time at the airport itself, like the actual airport terminal, like tarmac and stuff. Yeah, we actually get to go up and out of the tarmac. Either that or up in the air traffic control tower. So y'all stay, y'all keep an eye out for that. It's gonna be super cool. Hit the gritty, bro. Hit the gritty. Right foot creep, boom, walking with a heater.
I think that right there is cool.
I like the lizard.
Yeah, the little dragons. The little, no.
The generic 3D printed dragons. We also got some benchies. Got big benchy, little benchy. Little benchy sounds like a rapper name.
That's easy. That's a lot easier than It's not as bad as I thought it was going to be. I was thinking it's pretty rocket science.
Who's Childers?
So I actually went to work for Jeff Bezos for 3 years and built the BE4. I might know a little bit about that.
What's the BE4?
The BE4 is a 550,000 pound thrust rocket engine.
Good God.
It looks just like this. Matter
When I
of
tell you
fact,
6 inches,
I will
that thing
show you.
could cut 6 inches like it's nothing. And this isn't a full 6, but that's what that water jet cut out.
Ah.
Just like that.
Okay, how long did those lizards take to print?
About 12 hours.
He's apparently the
That
one.
was a while ago, so I pulled it up. So this is the actual engine. This is one of them that I was actually working on.
He has like the exact same photos.
Whoa, what are the applications of this engine? Fancy.
To launch a heavy payload into space.
Wow.
So that is a 6 foot tall man. That kind of gives you an idea. And the parts that I worked on is this, the LOX boost pump, and the MFV main fuel valve. I actually did all the pipe.
Was that an Air Rocketdyne?
No, this was at Blue Origin.
A Blue Origin. I
Ooh,
was there
Blue
last year.
Origin?
Oh, were you?
We're done in a moon tree over there. My
That's
wife and
cool.
I.
So there's another.
Oh, sorry. Yeah, I think that will conclude our live stream for now.
We must go.
I must go. My people need me.
No, I wanted him to finish the sentence that you asked.
Which way do we go?
This way, I believe.
No, you can link the video to the Warp Under Dev right now.
Huh?
You can link everything to the Warp Under Dev.
Oh, I
You can
will.
leak more documents.
Leak government documents. Leak government documents. For legal reasons, that is a joke. I must go. My people need me.
What's peak viewers?
Huh?
What is your peak amount of viewers look like?
Like 34 or something. Yeah. It's probably the most I've ever had on a single live stream. And we are back out here in Blackhawk land. Contrary to popular belief, BBC actually stands for Big Black Hawk helicopters. Or Big Black Hawk choppers. Kill this man with hammers. Not him, this guy. Nice music, bro. Yeah. Here's the Black Hawk without the tail.
Hey guys, I thoroughly enjoyed it.
Hey guys,
I hope y'all did
I'm gonna get some water. Shout out to these boys. What's up? Say hello to the live stream. I'm gonna try and end it exactly at 2 hours. Yeah. Is that fun or what, guys? It's probably one of my longest live streams ever. Gonna go live at least 1 or 2 more times today.
So it's a safety issue because the aircraft is on jacks. Don't go beyond the air. You can't go beyond that rope. Everybody turn around.
Shout out to unnamed guy painting the tail landing gear on this Black Hawk. Shout out to my boy.
Taller than you were in front of me.
Taking a picture right now. So I'm,
Yeah.
Please do not take that out of context.
It is hard not to.
You're gonna get so clipped on that.
Oh my yeah, we're getting clipped. That's my call to arms to you people. I need y'all to clip that and make it go viral. Make hashtag suck squeeze bang blow a thing. Make hashtag suck squeeze bang blow an actual thing, guys. The 2 people that still in the live stream, that is your mission. That is your mission today.
Remember, what are the 3 things that limit you in the aircraft, in the engine? Speed, fuel,
And heat. Let's go.
Remember, chat, we're talking about aircraft.
Alright, that's it for the live stream. Remember, suck, squeeze, bang, and blow, guys. That is gonna be the channel's. I got 8 now. I was at like 34 or something earlier. That is gonna be the channel's new slogan: suck, squeeze, bang, blow.
Hunter, you learning something? Hunter, are you learning something?
Yeah, we learned suck, squeeze, bang, and blow. That will never not be funny, chat.
I was about to hit the emergency button. Oh, we gotta get in the back.
That's like the bop it, twist it, pull it. That thing, that's what that reminds me of. Oh look, little ERJ. Check it out, chat. Little ERJ. Not an ERJ, Embraer E-Jet. Check that out. Alright, that's it for this live stream. Remember, chat, suck, squeeze, bang, blow. Alright, I shall see y'all in about an hour.
I'm basically a grown man. Like, come on.